Understanding orbital parameters. Unlock the secrets of space. Hello, and welcome to our latest video. Today, we're going to dive into an exciting and somewhat complex topic that's crucial for understanding how objects move in space. We're talking about orbital parameters. Whether you're a space enthusiast, a student, or just curious, this video will break down the concept into easily understandable parts. So, let's embark on this cosmic journey together and unlock the secrets of orbital parameters. Orbital parameters, also known as orbital elements, are a set of numbers that describe the shape and orientation of an orbit around a celestial body. Think of the Earth orbiting the Sun or a satellite orbiting the Earth. These parameters are essential for scientists and engineers to predict the positions of planets, satellites, and spacecraft at any given time. The most important thing to understand here is that orbital parameters help us map out the path an object takes as it moves through space, ensuring that satellites don't collide and that space missions are successful. There are 6 primary orbital parameters that describe an orbit in 3-dimensional space. Let's break them down. 1. Semi-major axis, A. This tells us the size of the orbit. Imagine an ellipse, a stretched circle. The semi-major axis is half the longest diameter of this ellipse. 2. Eccentricity, E. This parameter shows how stretched out an orbit is. An eccentricity of 0 means the orbit is a perfect circle, while values closer to 1 indicate more elongated orbits. 3. Inclination, I. This is the tilt of the orbit's plane compared to the reference plane. It tells us how much an orbit slants relative to a baseline, such as the equator of the Earth or the plane of the solar system. 4. Longitude of the ascending node, omega. This complicated-sounding term simply specifies the horizontal orientation of the orbit. It tells us where the orbit passes upwards through the reference plane. 5. Argument of periapsis, omega. This details the orientation of the orbit's closest approach to the celestial body it's orbiting. It's like pointing to the spot in the orbit where the object is nearest to what it's orbiting. 6. True anomaly, nu. At a specific time. This parameter tells us where an object is along its orbit at a given moment. It's the actual position of the spacecraft or satellite in its orbit. Understanding orbital parameters is not just academic. It has practical, everyday applications. Here are a few examples. Satellite television. To receive a clear signal, your dish needs to point to a satellite in a geostationary orbit. Knowing its orbital parameters helps position the dish correctly. Space missions. Orbital parameters are crucial for launching satellites, sending missions to other planets, and ensuring spacecraft can return safely to Earth. Astronomy. Astronomers use these parameters to track celestial objects, study distant planets, and even search for exoplanets. We hope this journey through the cosmos of orbital parameters has been enlightening and enjoyable. These parameters are the language of the universe, allowing us to navigate and explore the vastness of space with precision and awe. Remember, the next time you look up at the night sky, there's a whole universe of orbits, each described by these fascinating numbers. Thank you for watching, and stay curious.